Today I'm going to show you what's inside of your car's braking system and how the ABS, traction, and stability control work. Now the braking system on your vehicle starts here at the brake pedal. When the driver hits the pedal, it's going to carry the force up this arm here that's mounted to the firewall and into the brake booster. Now the brake booster is this big black thing over here on the other side of the firewall. It's got a vacuum line attached to it and it multiplies the braking force. The force is then sent through the master cylinder, which is down here. It's going to take brake fluid from here and turn it into hydraulic pressure through the brake lines to the ABS actuator. Now on this car, the ABS module is located right over here. It's going to take that hydraulic pressure and distribute it to each wheel individually to prevent lockup. Finally, that hydraulic pressure is going to reach the caliper where it's going to clamp on the disc to slow down the wheel. Man, I really could use some new brake pads. So here we've got the entire braking system removed from the vehicle. Here we have the brake pedal. Here we have the brake booster and the master cylinder assembly. We have a couple of brake lines over there, an ABS actuator, the caliper and the pad assembly, as well as some of the electronic components that control it all, including the ABS computer, the yaw rate sensor, as well as the steering angle sensor and wheel speed sensor. Now we're going to start with the brake booster because it's obviously the elephant in the room. Here's where the brake pedal is going to connect to and push up against this booster. We have this vacuum connection here. We have the reservoir for the brake fluid here and the two outlets from this master cylinder. I'm just going to unbolt this master cylinder. So here we've got the brake booster and you can see there's a kind of valve inside of there. And as I press it down, it makes noises. Now this brake booster has an adjustment nut on the back here so you can adjust pedal travel. Now the brake booster is the essence of your power braking system. It's going to take inputs from the brake pedal here and multiply its force using the vacuum over here so that it can push really hard on the master cylinder in order to be able to stop a 3,000-pound vehicle with just 4 of these calipers. In order to see what's inside, I'm going to start taking things apart here. So I'll start by removing this little washer. Then I'm going to remove this little dust boot. And then inside of here we have a little air filter. That's to filter any air that goes inside of here from the atmospheric side. And then there's a secondary filter here. Who would have thought your brakes have an air filter? Now this brake booster is crimped all the way around, so the only other way to get a look inside is to use a special decrimping tool. That thing took a whole blade to cut through. Now there is a spring inside. Now inside of this brake booster we have a giant diaphragm and it's made of this rubber-like material here, and it actually separates the front half of this brake booster from the back half. Now on the front of the booster we have this large return spring here and that pushes back on the diaphragm when you release the brake. We've also got this vacuum inlet here. Now the way this brake booster works is we've got engine vacuum that's always applied on this side of the diaphragm. Now at idle, when you're not pressing the brakes, engine vacuum is also applied to the other side of the diaphragm here in order to maintain equilibrium between the front of the diaphragm and the back of the diaphragm, and that's achieved through this valve in the middle here. So now if I remove this rubber here, now without the brakes depressed, the vacuum is going to creep through this valve here to balance with the other side, but as soon as you start hitting the brakes, you'll notice that there's a spring inside of there, and as soon as you hit that brakes, what it's going to do is completely lock off any vacuum from going to the other side of the diaphragm and allow atmospheric air to enter through that air filter that we took off earlier from inside the cabin. Now that you have atmospheric air on this side of the diaphragm and vacuum on this side of the diaphragm, it's only going to push the diaphragm towards this way and therefore assist or boost any force coming from the brake pedal on this side. Then I can pull out this shaft. This activates the master cylinder and you can see there's actually an adjustment on it so you can adjust your brakes. And you can see the little valve inside of there as I press it from the back, how it moves. So when you first touch your brakes, it's going to activate this valve first before activating your power brake. But to get a closer look at this valve, I'm just going to make a little incision along here to separate it from the diaphragm. Then if I remove this from the housing, you can see that there's this giant rubber O-ring which is going to butt up inside of there, and that's going to first block all of the vacuum coming in this way before applying the brakes. Just pop off that reservoir. Now since brake fluid is hydroscopic, we do have a cap to seal off this closed system. Inside of here we have a filter, and then further inside of there we have a level switch which is going to tell the computer if your brake fluid is too low. Now the type of switch here is called a reed switch. Now the reed switch is just a magnetically sensitive switch. It reads open circuit when nothing's attached to it. When in the presence of a magnetic field, the resistance goes to 0, and that's what's going to send a signal to your dashboard to warn you that your brake fluid is low. And here we have the master cylinder, and in fact it's actually 2 cylinders that are in series to each other. One is in here and the other one is in here with its input from the reservoir here and output respectively. And I'm just going to use some snap ring pliers to remove the snap ring. Now in order to get this piston out, you would normally use compressed air, but I'm just going to make an incision along the top here. Now there's this rubber seal at the top here in front. I'm just going to remove the first set of pistons here. There's actually a Phillips screw holding in the second piston. And now I can take out the second piston. Where's the piston now? That's the return spring. That second piston's proving a little stubborn. Turns out there's actually this retaining pin that you remove, and then the piston should be able to come out. There we go. Now here we've got the master cylinder laid out here. I've got the primary cylinder at the front here and the secondary cylinder at the back. And the reason why they do this is because of redundancy. This is going to control two wheels, and this is going to control the other two wheels. So if there's a compromise in the seal here or something starts leaking on one cylinder, we can still bring the car to a safe stop using the other two wheels. Now if we take a look at the overall system diagram of the braking system, it starts here at the master cylinder, which receives pressure from the brake pedal and booster. It's then going to be sent over to the ABS actuator, which is then going to send that pressure out to each individual wheel. Now based on the speed and angle of the vehicle is traveling, as well as the driver's intended direction, the ABS module is going to calculate if the vehicle is understeering or oversteering. In ABS mode, it's also going to detect if one of these wheels here decide to lock up completely, or under hard acceleration if one wheel is spinning faster than the other. Now depending on the condition, the ABS module is then going to send a signal out to the ABS actuator to pulsate the brake pressure going to the appropriate wheel to bring the vehicle back into control. It can also send a signal to the engine control module to close up the throttle body and reduce the engine torque going to the wheel. Next up, we're going to take a look at the ABS actuator. Now looking at the top here, you can see you've got hookups for the front wheels and the rear wheels here, as well as the primary and secondary master cylinder. On the back here we have the motor, as well as a pressure sensor. Got some wiring over here that leads up to this relay box, as well as this wiring harness that goes to these solenoids inside of here. Now the most obvious part is this big motor, which drives the pump inside of here, and that's responsible for generating hydraulic pressure when the ABS is actuating. That way you don't bottom out your master cylinder. Now if I connect this pump to a battery, you can listen to it actuate. Now these two Torx bolts are really proving difficult. And here we have the motor cover. And inside of here we have the magnets for this DC electric motor. Here we have the armature that spins around with the coils wrapped up inside of here. Now just beside the motor we have this pressure switch, and that's going to tell the ABS module how much braking force is being applied. Now if you look closely inside of there, those are where the brushes are. There's 4 of them that connect to this power source. And next up I'm going to remove these bolts that house the solenoid. And then now I can remove that housing with the wires, and we can see the solenoids inside of here. This looks pretty cool. There's 12 of them. Some of them are blue and some of them are a gold kind of color. Now with the solenoids reinstalled, you can hear that clicking sound, and that's the solenoid activating the valve inside of the ABS module. Now if I remove one of these solenoids here, see, it's got the 2 terminals on it that you apply 12 volts to, and it's simply just a coil inside of there that forms an electromagnet, and that's going to either suck or push on that valve inside of the valve body. Now further inside of there, you can see that there's little terminals that form a circuit that interface each one of these 12 coils with one of these 12 wires, with this big black one being the ground wire. Now the valve body itself has these little caps on it that hide the valves inside that are moving back and forth. They are spring loaded, so when it releases, it's going to allow fluid to flow through. Now there's 12 of them here, and each one of them has a function to either be the input or the output for each individual wheel. Now next I'm going to cut open this valve to see what's inside. And once the cap is cut off, you can see I can pull out one of these little valves here, and this valve is what's responsible for either blocking or allowing fluid flow according to how the solenoid controls it. I'm just going to open up this area around the pump here, and then now I can pull off the entire DC motor assembly. Now the DC motor itself has an eccentric cam on it that rotates off center. See, it wiggles as I rotate it. And as that cam rotates inside of here, we have these 2 pistons on either side that can pop in, and as you push those in, it's going to generate a little pulse of pressure. And as you continuously rotate that motor, it's going to generate a continuous amount of pressure as long as the ABS is actuated. And you can see when I connect that motor just how the ABS spins. Got quite a lot of torque. Now if we take a look at the hydraulic circuit diagram inside of this ABS actuator, you can see that the primary and secondary side are completely split down the middle for the front left and rear right calipers, as well as the rear left and front right caliper. Then in the middle here we have the pump, and it consists of just 2 pistons that move back and forth here. Now it's going to generate extra hydraulic pressure that your master cylinder couldn't otherwise generate from you just pressing the brakes, while the ABS is actuating the solenoid. Now over here we have the inlet and outlet solenoids for each caliper respectively, as well as a switchover solenoid so that the ABS module controls this side of the circuit. Now if we take a look at the wiring diagram for the ABS unit, we have the computer which sits front and center. Now it's going to interface with the ABS motor, as well as the 12 solenoids and the pressure sensor in the actuator. We've got wheel speed sensor readings going in here, a speed sense going into here, as well as the yaw rate and steering angle sensor bringing in signals. We've also got power coming in from the solenoid. Now each one of those solenoids solenoids are going to kick in according to this design table here, either when the ABS is turned off or when it's activated. Each one of these wheels here have a combination of the solenoids that allow the brake pressure to work through. Now if we shift gears a bit and take a look at some of the electronics that control this braking system, we're going to start here with the yaw sensor. Now this is responsible for telling the computer how much your vehicle is rotating about its vertical axis, so it knows if you're drifting, and it's typically located underneath your center console, somewhere near the center of gravity of the car. Now this one here says do not drop because it has a sensitive gyroscope-like device in here that could break pretty easily. Now I'm going to cut this open to see what's inside. Check it out, inside of here, these are actually soft mounted, and you got some delicate wiring. So I was right, these are soft mounted on these little rubber feet here, and that's probably to prevent it from getting damaged on impact. And inside of here we have the component that acts like a gyroscope. Alright, we're going in for the kill. So lift off the top. Ow, it's hot! Ooh, it's still hot. This thing is like an aluminum heatsink or something. Now there is actually a magnet built into here, and all the dust is actually caught onto it, so I'm just going to use my wife's little toothbrush to clean this whole thing off so we can have a closer look. Now, using that toothbrush was actually pretty bad because I think I damaged it here. Now the heart of the yaw sensor relies on this micro electromechanical device here, or MEMS device. Now it has this little small mass in the middle here that I kind of broke. It's usually suspended here. You can see it move around with my toothbrush, and it's going to move up and down and side to side when the vehicle is rotating around its yaw axis, and that's going to be picked up through the circuitry here through a change in capacitance, and that's going to tell the ABS module to apply the brake to one side to straighten the vehicle in a dynamic stability control situation. Now, a simplified MEMS device is mostly made of silicon, and it can be represented in two directions like this. We've got a mass in the middle here that's tied to springs on either side, and as this moves back and forth due to the acceleration, it's going to create a distance change between its webs. Now if we put fixed plates in between these webs, we can measure the capacitance change of this acceleration and pick that up into the sensor and feed it to the computer. Now a yaw sensor is better represented in two directions to measure angular rotation, and you see it's represented here by this mass sprung by an X spring and a Y direction spring, as well as capacitors respectively. Now next up we have the steering angle sensor. Now this rotates with the steering wheel to tell the ABS computer what the intended driver input is so it can straighten the vehicle accordingly. Now this says don't drop or don't disassemble, so you know exactly what we're going to do on this channel. I don't have the security torques for this screw, so I'm just going to have to grind it open. Now inside the middle here, there's actually a gear that rotates these two gears inside of here. Now inside the steering angle sensor we have these two gears here that rotate independently of each other, but they both rotate with the rotation of the steering wheel. Now these gears are magnetic, and they relate to an encoder over here to pick up a signal. Now there's two of them because of redundancy to make sure everything's working inside of here. One of them is going to increase in voltage as you turn the steering wheel to the right, for example, and the other one's going to decrease as you turn it to the right. Now unlike the yaw sensor, this actually communicates directly through the CAN bus system to the ABS ECU. Now the way stability control works is it activates the brake on one side of the wheel, which is going to create a moment allowing the car to rotate about its center point here into the intended direction according to the steering wheel input from the driver. Now in an understeer condition, when the vehicle is turning at a larger radius than what it's intended to turn according to the driver's input, the VSC system is going to apply the brake to the inside rear wheel, which is going to create a compensating moment to rotate it in this direction to bring it back into the course that is intended by the driver. Now in an oversteer condition, some people call this drifting, the vehicle is turning at a radius that's much tighter than the intended course according to the steering wheel input. So the VSC system is then going to apply some brakes to the front outside wheel, which is going to create a compensating moment in this direction here, which is going to straighten the vehicle's course, bringing it back in line where it's intended. Now most ABS sensors are just Hall effect sensors that pick up the signal from the splines on the CV shaft and send it to the ABS computer. Now by using diagnostic software, you can access a lot of data coming off of that ABS module, one of them being the wheel speed reading. So watch as I put the vehicle into drive as this wheel here accelerates and you could read the wheel speed. Now we come to the brains of the braking system, the ABS control unit. I'd expect screws, you know. Now I could just pop that cover off. Now this computer is responsible for the ABS, stability control, traction control, as well as the electronic brake force distribution system in this vehicle. And how could we forget the calipers, which ultimately do most of the work in the system. Now its operation is really simple. You just have hydraulic fluid that goes into here, and that's going to pop this piston out to squish this pad against the rotor to stop the wheel. Now the brake pedal in this vehicle happens to have 2 stoplight switches. It's basically a giant arm that helps to multiply the force, and inside of here we have a return spring. Now the next time you stomp on your brakes, think of all these components that go into the braking system to make it work. Now make sure you change your air filters often, follow me on Instagram for more behind the scenes footage, and subscribe for more videos just like this one.